Welcome to Pioneer's Knowledge Hub.
Have you ever wondered if it would be possible to connect your brain directly to a computer? Welcome to the fascinating world where neuroscience meets technology, a realm where thoughts can drive actions beyond the confines of our physical body. Neuroscience is the scientific study of the nervous system, with the brain as its superstar. A marvel of nature, the brain houses billions of neurons, tiny cells that communicate with each other via electrical and chemical signals. These signals form the basis of our thoughts, feelings, and actions. Now imagine a technological interface that could decode these signals directly from the brain. This is the premise of brain-computer interfaces, or BCIs. BCIs strive to translate brain activity into computer commands, essentially creating a direct communication pathway between our brain and external devices. Incredible, isn't it? Picture this: a world where your thoughts can control a computer, a prosthetic limb, or even a drone. Imagine the possibilities if we could tap into that communication directly. Now this is where the magic happens: brain-computer interfaces. In the realm of neuroscience and technology, brain-computer interfaces, or BCIs, are the unseen wizards. But what exactly is a BCI? Picture this: you think, and your computer does. That's the fundamental concept. A BCI translates your brain activity into commands for a computer or other devices. It's like having a direct line of communication from your mind to your machine. The mechanism is quite fascinating. BCIs use sensors to detect signals from the brain. These signals are then decoded and translated into commands that can control external software or hardware. Imagine controlling your television just by thinking about it, or typing words on a screen using only your thoughts. This isn't science fiction, it's the magic of BCIs. The potential applications of BCIs are as vast as they are astounding. In the medical field, for example, BCIs are being used to help people with mobility issues regain control of their lives. Picture a person who's lost the ability to move or speak due to a debilitating condition. Now, imagine them operating a wheelchair or communicating through a computer, all with the power of their thoughts. This isn't a distant dream, it's happening right now. In fact, there are already real-world examples of BCIs in use today. Neuroprosthetics, for instance, are devices that can replace or improve the function of a damaged body part. They work by tapping into the brain's signals and turning them into movement. There are people today, amputees and people with paralysis, who are using neuroprosthetics to walk, grasp objects, and live more independently. And it's not just about restoring lost functions. BCIs also hold promise for enhancing human capabilities beyond their natural limits. Imagine downloading a new skill into your brain, or controlling a swarm of drones with a thought. The possibilities are mind-boggling, and we're just scratching the surface. Interpreting brain data is like trying to understand a foreign language. And like any language, it has its own unique grammar, syntax, and vocabulary. Only here, instead of words and sentences, we're dealing with electrical signals and neural pathways. The brain is an intricate network of neurons that communicate through these signals, creating a symphony of activity that underlies every thought, feeling, and action. But deciphering this symphony is a Herculean task. One of the main challenges in interpreting brain data lies in its sheer complexity. The human brain has approximately 100 billion neurons, each of which can connect to thousands of others. This results in a dizzying array of potential patterns and interactions. Moreover, these patterns can change from moment to moment, adding a dynamic element to the mix. Another challenge is the individual variability in brain patterns. Just as no two people are exactly alike, no two brains are identical either. Each person's brain has unique wiring, shaped by their genes, experiences, and environment. This means that a signal pattern that corresponds to a specific thought or action in one person may not hold the same meaning in another. So, how do we tackle these challenges? The answer lies in the use of advanced techniques such as machine learning. Machine learning algorithms can sift through vast amounts of data, identifying patterns and relationships that might be missed by the human eye. They can also adapt and learn over time, becoming more accurate and nuanced in their interpretations. Furthermore, researchers are beginning to appreciate the importance of studying individual differences in brain patterns. By tailoring their interpretations to the specific characteristics of each person's brain, they can achieve more accurate and meaningful results. As we get better at interpreting these signals, the potential applications of brain-computer interfaces continue to grow. With each stride forward, we're not just unlocking the secrets of the brain, we're also opening up new possibilities for communication, rehabilitation, and even entertainment. But that's a topic for another scene. For now, let's revel in the challenge and the promise that interpreting brain data holds. So, where are we headed with brain-computer interfaces? The answer is as intriguing as it is exciting. As we refine our understanding of the brain and improve our technology, the potential applications of BCIs seem limitless. Imagine a world where individuals with mobility impairments can control prosthetic limbs seamlessly, just as they would a natural limb. Picture a future where mental health disorders like depression or PTSD can be treated more effectively by directly interfacing with the brain. Or envision a time when our cognitive abilities can be enhanced, giving us the power to learn new skills or languages at a much faster rate. However, these advancements come with ethical considerations. As we push the boundaries of what's possible, we must also question what's appropriate. The future of BCIs is not just about technological progress, but also about navigating these complex moral landscapes. As we continue to explore this frontier, we don't just learn more about our technology, we learn more about ourselves. In this journey of discovery, we've barely scratched the surface. From the captivating intersection of neuroscience and technology, we've traversed the landscape of innovation, delving into the magic of brain-computer interfaces, or BCIs. These fascinating devices that bridge the gap between our minds and machines have been a central theme, demonstrating the limitless potential of human ingenuity. We've also grappled with the complex challenge of interpreting brain data, a task as intricate as the neural networks it seeks to understand. Yet despite these hurdles, we've seen a glimpse of what the future of BCIs may look like, a future teeming with possibilities, from enhancing human capabilities to unlocking new methods of communication. This exploration has just begun. And as we stand on the precipice of this new era, we are reminded of the vast expanse of the unknown. As we continue to unravel the mysteries of the brain and push the boundaries of technology, who knows what the future holds?
Please do like, share and subscribe to my channel. Thanks for watching.